Okay, so I'm Jody Hagins, and I'm actually glad to see you guys here. I was actually afraid I would be in this room by myself. I got John Kalb over there throwing C++ hand grenades, and Steve Downey talking about concept maps. And I really thought that I'd be in here talking to myself. So I'm glad you guys are here. Today, I'm going to talk about software design. The times I have spoken, most of them have been pretty deep C++ topics. We're going to talk about C++ because this is a C++ conference. But we're going to talk about design. And hopefully, we will also talk about design as it pertains to other things, not necessarily just C++. Because as C++ programmers, I imagine that most of us have to do things other than just hack away on C++. We have to distribute our applications, our libraries. We have to be responsible for lots of other things in systems that run our code. So we really have a lot of other responsibilities. We're going to talk about that a little bit. So if you want to get in touch with me, this is a very highly opinionated talk, and you might disagree with me. So feel free to send an email to me and get in touch with me. I'll be glad to receive. No, this is actually my contact information if you really want to talk to me. I actually do enjoy speaking and talking with people about things that we don't agree on. I mean, after all, if all we do is sit around and agree on everything, that's going to be a boring conversation. It's going to be a boring life, and neither of us is probably going to learn much. Really, when we learn is when there's some dissonance that we have to resolve. And usually, we learn when we have that dissonance and we're strongly in favor of our own position, but we're willing to move. Once we entrench ourselves and refuse to move at all, which we'll see a couple of times, then it's really hard to learn and move. But experience does that to us as humans. We have experiences. I don't ever want to do that again, so I'm never even getting close to it. But this talk is about design. And where did this title come from? I'm sure, where did this title come from? Scott Meyers, yes. Yes, indeed. So the title for this talk, Scott gave this talk a bunch of times. And his thesis is that the most important design guideline is to make interfaces easy to use correctly and difficult to use incorrectly. I don't disagree with this guideline. I postulate that there is a guideline that's even more important. And so before we talk about what that is, I want to look at some guidelines of some libraries that are well respected within our own C++ community. So I'm not here throwing rocks. Those will come later. But I just want to see some projects and what they say about themselves as far as what their design guidelines are. So this is Eigen, really popular, very well-written library. So it's designed so that virtual functions are avoided, achieves polymorphism with CRTP. The design avoids multiple inheritance. They basically say down here at the bottom, it's crucial for them to have the empty-based class optimization. So this is basically what they say. That right there, their design principles, that's this whole thing. That's their section. And I'm not going to judge. I don't think there's anything wrong with it. You write a library, you decide what your guidelines are going to be. But that's theirs. How would we sum up these design principles in a few words?
Performance at all costs.
Performance at all costs. This is C++, right? I stole John's moniker, but that's what you would get if you were in his talk. So performance. That sounds like the number one design criteria for Eigen. How many of you ever used Eigen? Would you agree that performance at all costs is their top design priority? So this is the C++ standard library, and this is directly from the website. Now those are the top two. It's kind of hard for me to obey the first one, but really hard for me to disobey the first one, really easy for me to disobey the second one. But I think they're kind of like, just Don't be smart. Don't be stupid. Don't be in the extremes. But I don't know that those are very concrete design guidelines. They have some other things about move-only types, allocators, and containers. They go on with other things with const correctness, class signatures, various things about types and generic components. And then they have this one, avoid inheritance and virtual functions where possible, which is interesting. Because, as we'll see later, and one of the things we'll talk about, is object-oriented programming. I've had several discussions with people this week. In fact, there's a whole section of my talk that is completely changed based on my conversations with people this week. But this is the main mechanism for object-oriented programming. And this is the standard library. Now, this is for the standard library. But it's like, we don't want to do this. This is our design guideline. But you do it if you want, right? So, and then there's a bunch of other things in here. My number one thing isn't in here at all. It's not mentioned at all. It might be implied by a couple of things. So let's look at boost, where this conference came from. Aim first. For clarity and correctness, optimization should only be a secondary concern in most boost libraries. This seems to kind of contradict Hagins' primary philosophy of design. Then, basically, a lot of the other ones are what I would call maybe implementation guidelines, not necessarily design guidelines for APIs, which is really what a library is, right? The library is about the API. It's not about the implementation at all. And then we have some other guidelines, names, naming conventions, exceptions, spacing, white space, how you format your code. There's lots of these. We get back to Scott's. We come back here, and we just looked, albeit briefly, at some documented guidelines for some popular C++ libraries. What API design guideline do you think is more important, or at least almost as important, as Scott's? What do you think?
Testability.
Sorry?
Testability.
Testability. I was at your talk the other day, so I believe you. Okay? Yes?
Optimize for change.
Optimize for change. Yes.
What is correct?
What is correct? Design for what is correct.
How do you know it is correct?
Oh, how do you know? Oh, yeah, I think that would go along with his, right? Okay. Anything else? Nobody said performance. That's striking to me. I would think that would be the first thing that people say. But maybe it's because we already talked about it earlier with Hagins. So before we go there, this is my required slide. People still try and argue with me and say that people don't need to know this anymore. But that's only people that don't have to worry about any type of code bases except things that they write themselves, and they already know this. This is the most important slide that I've seen in my lifetime as a C++ programmer. This is my favorite slide. It's the only one I've actually ever printed out and stuck to my wall until I memorized it. But I have a terrible memory, so I just stuck it there. And Stefan actually sent me a mouse pad. When I said this last time, he sent me a mouse pad with that on it. So I have a mouse pad with that thing on it. Wasn't that cool of him? Anyway, so here you go. How many of you guys, is this somewhat new to you? Some. Okay, great. There you go. Look it up. This is the number one thing. Testability. I argue that this is a much more important design guideline than Scott Meyers. Though I would say that his probably is inferred by it. Because if you make things testable, then they should be easy to use correctly and difficult to use incorrectly, because that's kind of what you're going to do when you're testing your API. But what does this really mean? So testability. What does that mean?
Able to test. Just take a test.
Okay, able to test. Thank you, Tony.
So that, I guess you would say that it's relatively simple to construct tests that can distinguish a correct implementation from an incorrect one.
Okay, that's a great answer.
I think this covers all the possible usage. As much as
Okay, all the possible usage, all the possible correct usage, and all the possible incorrect usage, right?
Yeah.
Okay. So I think that really what it means is that you ask this question: how am I going to test that? Whenever you're designing anything, if you're going to design anything related to software, I imagine hardware engineers and those guys have similar things, but I haven't really done that. But you see something, I'm going to build something, I'm going to make it. The very first question should be, how am I going to test it? But shouldn't I worry about performance? Well, yeah, you should. So that needs to be a criteria of design. But let me ask you, you notice that it's got low performance, so I want to go change the performance. How do you know that you just didn't make it faster, giving you the wrong answer? If it's not testable. It has to be testable in order for you to actually ever optimize, unless you believe that you're going to implement it the very first time and it's going to be as fast as it ever needs to be.
You can also say that you can test the performance. So testability is also important for performance.
Exactly. You have to be able to test the performance. So here's a mantra that the folks that work with me have heard me say, and so here's the deal. I hope I don't offend you. You can say you care about performance all you want, but unless you can consistently and continuously test that performance, then you don't care about performance. Because you never know if it ever regressed or how it's doing. You have to continuously and consistently test performance. I am super, super grateful that within the past year, we've got somebody on our team that has just been able to completely build us an entire new performance lab. Do all this, and now, I mean, it's awesome. If you don't have that, then you can say you care about performance. Same thing with quality. So I agree with that. By the way, I've got a ton of slides. I'll never get through them all probably. But I don't care because the conversation along the way is more important. All right, I've kind of done that. Though I really do want to get to the end stuff because it's what I'm kind of passionate about. So these are talks this year. These are about design choices and very closely related to how I view designing for testability. Really? Somebody the other day said in one of these talks, I don't remember which one, I don't remember which one, said functional is the one I like the best because it's easy to test. I do not disagree with that, which will be important for a quiz later. And then these are directly about testing. In fact, Michael, that was his right there. All about testing. So this right here, developing better code by isolating decisions, it's all about testing. That's what the whole entire talk's about. It's awesome. And then we've got this one, which was yesterday, testability and API design. So you can see that this week, there's been at least 10 talks that cover things that were in my talk when I got here on Monday. So my talk is drastically different than it was when I got here on Monday. Hopefully, the concept is the same. But the content is different because, number one, And there's a couple reasons. Number one, I don't want to just repeat a bunch of stuff other people have said. But number two, I actually have differing views from a lot of it. And I don't necessarily want to contradict those things because I really don't care. Because if in the end, their number one goal is testability, and they go about it a different way than I do, I'm fine with that. I don't mind that. You don't have to agree with me. You're allowed to be wrong. That doesn't bother me at all. So this is all great. This is all from this week. So my talk is, you're not going to learn new testing techniques. You're not going to learn new ways to test your code. What you are going to get is a whole bunch of questions to ask yourself around your entire system of APIs. So why is testing important? To ensure correctness?
Because we're human.
Because we're human. That's my answer. That's actually what's written right here. So maybe some of you have heard me say this before, maybe not. There are two things that I've learned over my years that every single human is really, really good at. There may be others, but these two things, every single human is an expert at. The first one is making mistakes. Every single human, I don't care how good you are, I don't care who you are, we are all really, really good at making mistakes. Sometimes those mistakes are in execution. Sometimes those mistakes are in judgment, which could mean that somebody's actually making a mistake on purpose, but really it was just a mistake in judgment. So everybody does this, and so we need tests because we're humans. Until the bots take all of our writing code away, we need to be writing tests. No, that's not true. Because, you'll see, testability does not mean writing tests. That's just one part of it. So, you might be wondering what the second one is. Normally, if I'm talking to somebody one-on-one, they'll say, what's the second one? But in a group like this, maybe not. Sorry?
You made an error.
That I made an error. Yes, that could be it. It's an off by error. Off by one error. But no, the second one is actually that the second thing that every human is really, really good at is being annoyed when other humans make mistakes. I mean, it's okay for me to make mistakes, but when somebody else makes a mistake, but we all do that. Testability is important. Oh yeah, I forgot to click the thing. We are human. I was going to do that when you said that. So
annoying.
it's a shame you weren't closer to the mic. All right, so let's get to the meat of this talk. So we've already talked about the word testability. And so how do you do this? How do you accomplish this idea of testability in your job?
Free function, pure functions, free functions.
Pure functions, free functions.
I generally try to break down things into as small pieces as possible.
Break them down into small pieces as possible. Modularization?
Yeah.
Independent modules?
Yes.
Relentless decoupling.
Relentless decoupling.
Basically the same idea.
Yes, relentless decoupling, or remove coupling. Would you say that relentless decoupling is the same as composition, or similar?
It enables composition.
Yeah. Okay. Anything else? Anybody else? So when I asked people this before, none of you gave the actual number one answer I got when I was asking people before. So I don't know if this next slide will be worth anything. That's what people usually say when I say, oh, it needs to be testable. Oh, we need to do unit tests. And sure, this is one way of ensuring testability, especially in isolated code. So it's time for an interlude. How many of you know who this guy is? Yeah, some, not everybody though. This is Donald Knuth. How many of you now know who this guy is? Okay, all right, that's better. He was very much focused on eradicating bugs in his programs, in everything he did. So much so that he offered bonuses for eradicating bugs in his stuff. And tech, I believe that bonus doubled either with every bug or every year. I can't remember which one. But still, that's a set of stones. I don't know any program I've ever written that I said, hey, I would open up to the entire world, and every time somebody reports a bug, I will double the reward. I don't know how many, well, no, we all understand powers of two, the 2 to whatever power, know what that means. We've played the chessboard game, right? So he really cares about testing. He really cares about quality. He tests his software. He proves his software. Sometimes he does one and not the other, as in this very famous quote that is at the bottom of a letter that he wrote to someone. He cares about it. So let's see what he has to say on testing. Now we know who this guy is. Anyone think he does not know what he's talking about when regarding programming? Okay, at least nobody's bold enough to raise their hand. So let's see what he has to say on some topics related to testability. This is from an interview in 2008, which for some of you was a long time ago, and for some of us, not long enough. In that vein, and I'm going to read, okay, because I don't know how well you guys can all see that. In that vein, today's developers frequently build programs writing small code increments followed by immediate compilation and the creation and running of unit tests. What are your thoughts on this approach to software development? As to your real question, the idea of immediate compilation and unit tests appeals to me as the ultimate silver bullet. I've been waiting my entire career for such an advancement in computer programming technology. No, he didn't say that. He said this. Whoops, sorry. As to your real question, the idea of immediate compilation and unit tests appeals to me only rarely, when I'm feeling my way in a totally unknown environment, and when I need feedback about what works and what doesn't. Otherwise, lots of time is wasted on activities that I simply never need to perform or never even need to think about. Nothing needs to be mocked up. What do you think about him now? Oh, I getting some clapping and some thumbs up back there. All right. I have to give a full disclosure before we go on. I'm a fanboy. Okay? I am not unbiased. All right? That's my little one.
I heard he had to stop doing this because people were framing the checks and posting pictures.
Yeah, but yes, but this is after he's actually stopped. Yeah. So he doesn't do this. Yes. When I put it up, I thought, you know what? Because here's the deal. I was actually going to just bring the real one and show you instead of put it up there. And I'm in the process of moving. And so I was in my new place and I forgot to bring I brought these stupid books and forgot to bring the check because it literally is in protection. But that's a picture of it. Yes, he had to stop doing this because there was too much check fraud on his account. Not from people he had sent them to, but because people would post it and other people would just grab the numbers. So yeah, he doesn't have this bank account anymore. So
Did you ever cash out the check?
I'm sorry?
Did you ever cash out the check?
Oh no. No.
Nobody.
This is truly one of my prized possessions.
Sure.
This is a prized possession of mine. We talk later about where it was. It was in, as you can tell, it was in volume 2. Basically, it was in the division algorithm.
What if anyone has ever cashed a check like this?
Yes, actually, some people have. I think when he stopped doing it, when he stopped doing the checks and started basically giving you the Bank of Sans Serif, I think is what he calls it. You get a certificate and you get actual money into the Bank of Sans Serif. But he said, I've stopped doing it. He said, in reality, out of the last 250 that I've sent out, only 9 have been cashed. And I'm thinking, somebody else must have reported the bug for those 9 people. Because if you really found something and reported it, you wouldn't have cashed that check. But yeah, so some people have. Anyway, So, what are the comments, questions, concerns, complaints about Donald Knuth's recorded comments here? Yes?
One of the comments, not like a complaint, but like I've heard that back in the day, the way people used to program was they would like basically prove everything correct on paper, and then they would go type it, and it would be correct. I have no idea how that happened, but I wonder if that's where he's coming from.
That is one place where he's coming from, and I can just say that I'm old enough to know a person who, when he first started programming, had to sit down and write his programs out because he had limited time sitting at a machine that you had to share with other people and punch out these stupid punch cards, one line per card, and then you had to take your stack of cards and hope you don't drop them over to the IBM 360 scanner and put them in and then wait 45 minutes for it to print your output and for you to get it and then look at your code and see that there was an error. That's not fun. Yeah, that does have a lot to do with it. Well, if you note, in the letter he wrote, he was basically, this guy had basically proposed all this stuff, and he's just saying, no, that doesn't work, here, try this. I think it was a queuing theory. And he proved it all, but that was easier for him than writing a program and saying, oh, here's the code, right? But he wrote the program out, and so.
So I feel like, to a large extent, I'm often working in a pretty unknown environment.
Okay. Yeah, and a lot of us, we are working with new things, novel stuff quite often. And yeah, if I don't know much about it, that's how I'm going to discover. And that's really, so, well, there's a lot of talk about TDD, and I'm not here to talk much about how people accomplish these things. Because honestly, if it works for you, great. I don't really care. But I think that one of the things that I like about the approach of writing tests as I'm programming is I am figuring out stuff that I don't know if I'm in an environment that I'm unfamiliar with. Yes?
To expand on the idea of an unknown environment, I feel like a code base that I personally wrote like 1 or 2 years ago is already an unknown environment mostly.
I can buy that. Anybody else? Yes?
I would like to know what appeals to him instead.
That's a really good question, and we will actually get to it.
What's your opinion on mock tests?
I'm sorry?
What's your opinion on mock tests?
His or mine?
Both means.
Well, he thinks that absolutely nothing needs to be mocked up, right? I'm not quite there. I think there are places for mocks. I really do, but not near as much as other people. I'm not everything needs to be mocked. As you'll see, I'm more of, let's define a well-testable interface of what needs to be done, and let's test that. And let the implementation be the implementation. And if the implementation has some hard parts that I need to discover, then I probably need to write tests for those parts of the implementation. But I need to understand that as I'm doing that, I'm tying myself to that implementation. And so I need to make sure that I don't do that too much, right? But it might be a way for me to figure it out. Yeah.
I have a question, which is, like, to what extent did he write things collaboratively with other people who are, not as awesome as him?
So there's a story, okay, that's told by a person that went to college with him. So whether the guy's making it up or not, I don't know. But here's how he did collaboration. He was sitting there at the punch machine, and I don't know how many of you guys have ever had to do punch cards. How many of you ever? No? Gosh, I'm the only one? No, I mean, my friend is the only one? Okay, all right, great. So when you do punch cards, here's the thing. There's like maybe 4 stations you can do punch cards. And there's a queue of 50 people waiting to use them. And you have to go sit there, and then you have to punch stuff out, and then you have a time limit because all those people are waiting. When your time limit is up, you get scheduled off the processor, right? You get interrupted and scheduled, and you're thrown out. So you have to type the stuff in, and then you have to get it out, and you have to go. The story of collaboration is that he told a guy was waiting in line. He was supposed to be next, and he told the guy, he said, how about if I type it in for you because I'm faster at typing and then I can keep going? And he said, okay. So he gave him his program on paper and he's typing. And he said sometimes he typed really fast and sometimes he was slowing down and sometimes he was typing really fast and sometimes he slowed down. But he got it done. He said he still ended up typing it faster than he would have. And he asked him, well, why why were you speeding up and slowing down? He says, oh, I was fixing all your bugs. So anyway, I think that's his collaboration. But he's an academic, so he does collaborate. I mean, he writes everything he does, right? It's all public. It's from the same interview. Can you give some examples that are currently in vogue, which developers, oh wait, hang on. All right. So Donald Knuth just threw that book in the trash. Can you give some examples that are currently in vogue, which developers should adopt simply because they're currently popular or because that's the way they're currently done? Would you care to identify important examples of this outside of software development? I'm not going to trick you this time. This is his reel, but I'll give it to you in pieces. I hate to duck your questions, even though I also hate to offend other people's sensibilities. Obviously, I do not. Given that software methodology has always been akin to religion, I think this is important. And Donald Knuth, if you guys don't know, he's an extremely devout religious man. He's written several books, what computer science really talk about. He wrote one on John 3:16, where he does an exposition, and drawings, an artistic renderings of every John 3:16 passage. He's a devout religious man. He says that it's akin to religion. Not on that, but on the fact that everybody seems to have their own belief structures. But he's famous for this. What's the title? What's this title? The Art of Computer Programming. Not the science, not the true way, not the only way, the art of computer programming. With the caveat that there's no reason anybody should care about the opinions of a computer scientist / mathematician like me regarding software development. This is an interesting sentence. He's being modest here. Some would say he's being false. It's false modesty. But there's a point here. There's a big difference between the fundamentals of mathematics and computer science and the practice of software development. And I also note that he says software development, not software engineering. I just thought that was kind of interesting.
When did he say this?
2008. Okay. So let me just say that almost everything I've ever heard associated with the term extreme programming. How many of you are familiar with extreme programming? You're familiar with it? How many of you have actually know what extreme programming is? You've read the books. You got the t-shirt. Yep, okay. Yes, that's what these are. There's agile software development. Just came here. Here's extreme programming explained. That was the first one. Extreme programming explained. Extreme programming installed. Planning extreme programming. Okay, so that's what he's talking about when he says extreme programming. Let me just say that almost everything I've ever heard associated with the term extreme programming sounds exactly like the wrong way to go, with one exception. The exception is the idea of working in teams and reading each other's code. That idea is crucial, and it might even mask out all the terrible aspects of extreme programming that alarm me. But he's not done yet. I also must confess to a strong bias against the fashion for reusable code. To me, re-editable code is much, much more better than an untouchable black box or toolkit. I could go on and on about this. If you're totally convinced that reusable code is wonderful, I probably won't be able to sway you in any way. But you'll never convince me that reusable code isn't mostly a menace. What do you think of this?
He's friends with Hiram.
He's friends with Hiram. How many of you agree with this? Okay, no, you know what we're going to do? We're going to do a strongly disagree, disagree, neutral, agree, strongly agree. Okay? Strongly disagree. 1. Disagree. 14. All right? Neutral. 2, 3, 4, 5, 6, 7, 8. 8. 9. Agree. 2, 3, 4, 5. Strongly agree. None. Okay. Yeah, I'm not gonna post that consensus. Okay. So anyway, this was 2008. I actually got more neutral and agree than I thought I would. I'm actually kind of glad to hear that, because I'm very big on testing. I mean, I really am. I think that, like I said earlier about performance testing, I believe it about quality, about your code. If you say you believe in quality and you don't consistently and continuously test, then you don't care about it. But I think there's a lot of merit to this on testing. So this gets to testing techniques. And Elias, I think you asked earlier, well, what does he do? Well, this is what he does. I generally get best results by writing a test program that no sane user would ever think of writing. My test programs are intended to break the system, to push it to its extreme limits, to pile complication on complication in ways that the system programmer never consciously anticipated. To prepare such test data, I get into the meanest, nastiest frame of mind that I can manage, and I write the cruelest code that I can think of. Then I turn around and embed that in an even nastier constructions that are almost obscene. And he calls these torture tests.
Someone should teach him how to fuzz test.
I think that's probably similar to what has done, right?
Yeah.
Except without that idea. But yeah, it does sound to me a lot like fuzz testing. I'm trying to create the worst situations of stuff and trying to see what breaks and what doesn't. So I don't think that his methodologies are just old and crusty. I think they are good methodologies. Now, personally, I think that a combination, it's just been proven since the 2000s that unit tests, I think there's a terrible definition for it, right? And a lot of people have different definitions, because to me, a unit is whatever the unit is. I'm not necessarily in favor of writing some class and writing some class that's implementing something and writing a test for every single function, even the thing that returns something. I just don't think that's necessary. So I agree with him in that regard. So I'm kind of in the middle with him. But I really like this. And in fact, to me, this sounds like fuzz testing, but you know what this sounds like more to me?
Mutation testing.
I'm sorry?
Mutation testing?
Mutation testing? Something else. Something I gave a link to someone the other day about. Property-based testing. Yes, this sounds a lot like, to me, like property-based testing, except it's doing this in an automated way. If you guys don't know what property-based testing is, I strongly suggest that you Google it, you look it up. I don't have time. Like I said, I'm not going to go into techniques. I've become an incredible fan of property-based testing. Here's my big caveat. Is the only good property-based testing framework that I've been able to find is RapidCheck, but the maintainer seems to have stopped maintaining it religiously, and I'm afraid that if I devote to it, I'm going to end up maintaining it. And I don't want to do that. So if you guys know of good property-based testing frameworks or something, or if you love this idea so much, Michael, and you want to fork that repository and maintain it, I would be indebted to you, personally indebted to you.
Google fuzz test has property-based testing in disguise.
In disguise. You'll have to show me how to manage that, because I haven't broken the disguise. So what can we take away from his take on testing? I think it's basically those things. But first, we have to ask ourselves, what is the purpose of testing software? So what do you think? What is the purpose? If I say the most important design criteria is testing, is testability, not testing, testability. And to me, that is summed up with asking, how do I test this? Every time I make a decision, how am I going to test this? And there's a corollary to that. Not only how do I test this, but is it going to inflict pain on my users when they try to test their stuff? Can they easily incorporate what I've given them, and I'm not making it a burden on them to use my stuff because now it's hard for them to test their stuff? So, yeah, like I said, I'm not really interested in debating the merits of different technologies. Use what you like. Or maybe we can have a discussion later about those things. I have my own view on them. Instead, I'm going to focus on things that are normally not talked about. Yeah, things you haven't heard this week. So, how do you test your software? What tools do you use to test your software? How do you guys test your software? What tools do you use? Just throw stuff out. Don't raise your hand, just throw it out.
G-test.
G-test, okay, a test harness. Gherkin.
TeamCity.
Yeah, TeamCity. Okay, yeah, I have to speak louder because you need to come into that microphone, otherwise it'll just be nothing on the video.
CI automation.
CI automation.
Run it like a user, try it out.
Run it like a user. That's kind of like what Donald Knuth said, right? Run it like a user, try it out.
Automated test like XPath.
Okay, automated test. Okay, so what if you were writing the guidance system for this thing? Who said that? Who said? Okay, great. All right. Then you will appreciate my story. You will at least be able to validate if they don't do it this way anymore. This is the way they used to do it in 1992. Okay. So if you used to do that and you do it the same way this is, then I love you. All right. So this is a Tomahawk cruise missile.
Oh, I thought that was an underwater vehicle.
Oh, no.
Wrong angle.
Okay, sorry. Yeah, this is a Tomahawk cruise missile. So I have a friend back in the early 90s, and his job was to develop the guidance system for Tomahawk cruise missiles. I don't remember exactly which cruise missile version it was, but it doesn't really matter. But here's how they tested the guidance system. They wrote a module that the guidance system hooked into that acted just like it was basically the cruise missile guidance module. All the software was doing all the cruise missile stuff. And then they had a module that converted that into commands for one of the helicopters that was in the military. I don't remember which helicopter it was. And so then they would take the cruise missile software up into the air, the pilot would go up, and at some point, the pilot would, turn the cruise missile guidance system on, and the pilot would let go. And the cruise missile guidance system would fly the helicopter. Now, it's good that there's a human being there to take over the controls, but it's not like an airplane. Airplanes are meant to fly. If something happens, at least they'll glide, you got a chance. Helicopters are flying rocks, right? So at the moment, if something really bad happened, then the whole thing's just going down. But, so this gets into the fact. Are you a believer in testing, or are you committed to testing? This is the difference between believing in testing and committed to testing. The chicken believes in breakfast. The pig is committed to breakfast. Right? And so not only would the module go up into the helicopter, the programmers would go up into the helicopter. So my friend, anytime they had live testing, he takes the software with him, he goes into the helicopter, he hooks it up, he goes into the back and sits down and hopes he fixed that last bug. Because he's actually in the helicopter. I find that very interesting. He's there. If something goes wrong, somebody needs to be able to maybe program it or do something. But really, he's there to ensure that he really cares about this test passing. So we talked about a lot of tools that you use for testing. There's one that nobody mentioned. And it's the reason that we're here at this conference. Why are we here at this conference?
C++.
To learn. It's all about C++. Not one person mentioned the compiler. And to me, and here's where I go off the rail a little bit, the most important tool in your testing tool bag is the compiler. How are you going to test this thing? What's the first thing you do to test this? Remember, the goal of testing is to ensure that there's no errors. What's the first thing you should do in testing this?
Read code. The documentation.
Read the requirements.
Figure out what a blarg is.
Okay, yeah, all right. So I've told you what do something means. You've read the spec. I argue that is the first thing you do. No naked types. I just don't believe in naked types in an interface. It just leads to all kinds of bugs. You should have strong types everywhere. This is, again, it's my opinion. I just don't believe that a naked type should be in an interface. You are asking for bugs. You're asking for someone to use it wrong. You should make things correct by construction. You should not allow this to happen.
But it's not testing.
I'm sorry?
What you've done is not testing. You're already acting on something. Testing is...
I am testing.
Testing is a discovery process, but it's passive.
No, that's why I said testability with all the different... There's a lot of different ways of testing. This, I'm testing it because that's why I said, what's the goal of testing? The goal of testing is to prevent bugs, to prevent it being used wrong. This prevents bugs. So this is using the compiler as your first line of defense. Your first line of, not necessarily, I'm not talking about running a test, but I'm talking about testing, making sure that there's no bugs. And so this cuts down on bugs. This is the very first line of defense, is using your compiler. That. But what about this? It's the same problem. I've got a strong type for the price. I got a strong type for the quantity. It's the same problem. See, I still call like string as a naked type. It's not a built-in, but it's a naked type. So it can be used for all the different things. Price and quantity can be used for lots of different things. They maybe aren't naked, but maybe they're topless. Or maybe they're string bikinis or something. I don't know. But they're almost naked. Or as we say back where I come from, they're almost naked. So I would say that this is a test. This tests that it's used correctly. Because you could invert those bid and ask quantities and bid and ask prices. And this prevents bugs. So when I talk about testability, I'm talking about designing interfaces that prevent bugs and allow correct execution. So there's a lot of strong type libraries, and there's a lot of them that are really, really good, and you should probably use them. For some reason, I find little nits with each one of them, and so this is what I've started doing. Run this through libclang and let it go generate all the stuff. This part right here just basically tells it what kind of operations and things it's supposed to have. So you can imagine that, and there's a struct flip. It's just a for declaration. The libclang generates the actual code for each of these, and it generates for whatever you have. I find this to be quite readable and does the job for me. So what do you test? What is an API? So I want to shift gears and talk about testability from a different perspective. Application programming interfaces is a very generic term. What we consider APIs. We know what C++ APIs are, but I'm going to talk about APIs in general. Anything that, back in the old days, they used to be called CTCIs, computer to computer interface, right? Anything that is an interface that involves the computer, the software you're writing at all. Even the interface that might involve a human at some point, because you need to somehow test that to make sure that it's right and it works. So the big thing, how am I going to test that? Whatever is part of your system, how am I going to test it? So this is a talk from last year, so it's quite recent. This talk, oh, you know what? I don't know if you guys are going to be able to hear it or not. Hopefully you will. This talk was about great mistakes in programming, and the speaker highlights a number of different experiences and events that have happened over the years. And I want to play the first bit of this.
But this is my favorite one, I think, in the whole talk, because they deserved it.
Now, nobody deserves it. I got angry when I heard this talk. Yeah, nobody deserves it. I don't care whether you think people that deal in the financial industry are good guys or bad guys, or whether people that designed the cruise missile. He goes up to test the cruise missile and it crashes. Oh, he deserved it. Yeah, I mean, nobody deserves this stuff. And I've been doing this for a long time. I've been in the financial tech industry since the 90s, and I pretty much haven't left it except for a stint where I took several years off to go teach high school math and coach football, which was a different story. So I want to talk about this because I think it's a great example for all of us. I will try to limit myself to discussions that are outlined in this official document. It's public information, anybody can see it, anybody can do it, and there's plenty to discuss there. Note the purpose of this document was not to do a postmortem on a software issue. The purpose of this document was to discover what, if any, rules and regulations were violated in this event. Okay? So for those of you that aren't familiar, Knight Capital is basically a market-making company. They were doing, some people will call them a hedge fund. They were a big trading company in the United States. And they had a big, huge event that happened in 2012, and they lost $460 million in one day, and they went away, pretty much. The SEC had to do an investigation, and this is their report. I'm not going to read everything. I'll kind of summarize these things, but I highlighted it so you can read through it if you want. But basically, over a 45-minute period, Knight lost about $460 million. And I want to discuss how this happened, not to throw anyone under a bus, because nobody deserves that. I've been directly in this field since the 90s, and there's lots of firms that have done every single thing that we talk about, including some of the ones that I've been a part of. Everything we talk about, almost, I think I've probably made that same mistake at least one time or not in my life, in my career. But I want to see, what does this mean for testability in general? Not just testing your C++ programs. Because your C++ programs are not just run in isolation. Some of you are on embedded things, but then you might be dealing with a heart maker or heart pacemaker. So basically, the New York Stock Exchange implemented this retail liquidity program. They actually applied to do this. There were some people that thought they would not get approval for it, including the people that ran Knight. Because at that time, there was a lot of blowback in the public about these types of programs, and they figured that the SEC was not going to allow NYSE to basically do this, but they were allowed. It meant that by the time they started doing their development, they were under a time crunch. So they basically had to change their software systems, and they were going to basically remove a piece of source code and replace it with a new piece of source code. And this wording is a bit confusing, but basically it just means that after they did that, the unused code was still a part of the system. We'll just use the word system because I don't want to get too deep in technical details there. They reused an existing flag. It's not exactly correct, but just think of it as an enum that's named PowerPeg set equal to 10. And they said, oh, you know what? We're going to remove all that code. And we're going to set our enum RLP equal to 10 in the new code. Okay? It's not exactly, but that's good enough. Or you can think of it as they're using something for bit number 3, and then they change the definition of what bit number 3 means. So this basically says that PowerPeg had some special order handling functionality. Basically, if you have an order, it would break it up into small child orders and farm those all out. And then as they got executed, they would all get accumulated. That's what this part, when it says, you read or see this part, it says cumulative quantity function. That's what it is. It's basically just computing the cumulative quantity of things that have been executed over time. And so that's basically what this thing did. So in 2003, they stopped using the PowerPeg functionality. So basically, their systems that were actually telling their other systems do PowerPeg stuff, they stopped that. In 2005, they moved how to compute that cumulative shares that was in the PowerPeg code, the earlier point in the code sequence. Now, they stopped using it in 2003, but in 2005, they refactored their code and they moved the PowerPeg functionality to a different place. They didn't retest their PowerPeg code after this. Maybe implies they didn't have tests before, because otherwise they would have just automatically failed if they had automated tests. I think you had brought that up. On July 27th, which was a Friday, they started their deployment process because it was supposed to go into production on August 1st, which was a Wednesday. They did a manual deployment to 8 server machines, and they missed one. So they had 8 machines running their production code. 7 of them get the new code. 1 of them did not. One person did what this part says is basically that one person did the deployment. They didn't have a backup person review it, and they didn't have any system tests that ran after the deployment was in place. This new functionality went live on August 1st. Remember, the functionality was already in the system before that, but NYSE hadn't been sending the special instruction that saying, hey, I'm doing this RLP thing. Okay, it hadn't been sent yet. So the special instruction saying I'm doing the RLP thing happened on August 1st. The 7 machines, the 7 machines that received the new code, processed them perfectly. The new code was perfect. It didn't have a single problem. Not one problem with all the new code. However, stuff that went to that one server that hadn't been updated saw the instruction to do RLP stuff and said, hey, I know how to do that. I'm going to go over and do this PowerPeg stuff because it was the same value. Remember in 2005 when they refactored the quote-unquote dead code and it got moved and rearranged? Well, now the cumulative quantity function, when they got the instruction to do the PowerPeg stuff, they're doing the wrong thing. But now it's even worse because the refactor in 2005 had moved the stuff that calculates the cumulative quantity. So it's sending out all these orders and all the information is coming back saying this execution occurred, but the cumulative quantity wasn't being computed. So it just kept repeatedly sending orders out over and over and over again because they weren't computing the stuff back. And I'm looking at your faces. Some of you guys know this. You're just looking at me like, yeah, dude. Some of you, this is the first time and you're horrified. But it's easy for you to make these exact same mistakes. I've made them. So one part of the system recognized that this was happening, but it didn't have communication with the part that was malfunctioning. And there was nothing that flagged and said, hey, our holistic system, there's bad stuff going here. There's something going on in the system, and we've got inconsistent information. One part of the system believes one thing, and one part believes the other, and there wasn't a way to detect that. And again, I'm just trying to present the information from here and not placing judgment at all. But this effectively ruined them. 460 million was the net loss about in 45 minutes. Now, that may seem like a lot. I personally was involved in a situation at a different firm where we had it wasn't this situation on this big basis, but it was another situation where something happened, something went wrong. And it was detected by somebody, and the red button for that thing was turned, and I believe it was probably like less than 60 seconds. And let's just say that the loss was in 7 figures in less than 60 seconds. So these types of bugs, they can really be disastrous quickly. Some parts of the system, this is what we had. This is basically what they're referring to later. But notice, at 8 o'clock a.m., those of you that aren't in the market opens at 9:30. But there's a lot of pre-market trading that happens. At 8 a.m., the system sends emails saying there's something wrong with this PowerPeg thing that hadn't been around for 9 years. Right? But it sends these emails. But those messages were not alerts. They were just log messages. They were just email messages that goes to somebody that ignores them because nothing ever important happens in those emails. I'm used to ignoring them. Why should I pay attention to them today? So even though they got them an hour and a half before the market happened, they weren't acted upon. So they did have a 33 account. That we normally call this like an error account. If a trade happens and you can't isolated. The system says, hey, I've got this execution, but I'm unable to determine where it actually goes. Normally what happens is it goes into an error account because you actually have them. And so this error account just started accumulating and accumulating, but there was no system in place to make a big alert that says, hey, the error account is oversubscribed. We need to do something. It just kept, they're just like, well, the error account's growing and we don't know why. So after somebody realized something was going wrong, the engineers finally decided to do a rollback of the system. So what do you do in a rollback? You go back to the previous version. So now, instead of one server running the old PowerPeg code, all 8 of them are running the PowerPeg code. So all 8 of them are misbehaving because it's not just because, yes?
At the time when they were doing the rollback, did they realize that they only had to roll back 7 of the machines and that there was no action that they had to do on the 8th, or they just...
Well, the thing they didn't really know the problem, and so they didn't understand what's going on. So what they thought was, let's just roll back to the previous version because it's been working for a long, long time. Because they didn't know what was going on. They didn't see that note about the PowerPeg until way after this event had occurred. If they'd have seen that PowerPeg thing, instead of rolling back, they'd have rolled that one machine forward, right? Because they'd have realized it, but they didn't. And I mean, that's what we do, right? Yes.
Wouldn't you, like, instead of rolling back to software, wouldn't you want to stop trading first?
Yeah.
It depends. So I'm not going to go into that because there's legal implications, there's loss implications. If you're a market maker, you are obligated to be making a market at all times. So you're supposed to make a market. The worst thing you can do is shut down. I don't think anybody realized that it was as big as it was until it got out of hand. But that's part of, like I said, I'm not going to go into all this stuff. Go read this. They talk about that later because that's a regulatory thing. There should have been a process in place. Somebody other than the programmer should have been in charge knowing something's bad, and they should have done something. But that's all that information is in this paper. But it doesn't have anything to do with the programming of it, which is really what I'm interested in. But the problem really wasn't the rollback either. It was that if you're going to roll back a system, you can't just roll back part of a system. The part that was accepting the RLP stuff should have been rolled back as well, right? This is one of my very favorite talks, like ever.
So how do we get a bug? Here's an observation from many years in the trenches. Most good bugs are team efforts. It requires cooperation from a number of people to produce a really good bug. So one bug here is hoping the comment is enough to dissuade people from sending something that's not then copyable.
So really good bugs require collaboration. It's my position. I posit, and I have ever since I've been in industry pretty much since the 90s. I probably know way too much about what really happened here. But we're just talking about what is in this document. But I posit that if any one of these had not happened, we would never know that this occurred. None of us. Because it would have been a non-event. What do I mean by a non-event? Well, our company was much smaller than Knight. We lost a lot of money. Nobody lost their jobs. Nobody knew about it. Changed process. But that's probably what happened. If any one of these things hadn't happened, it pretty much required like what they call the perfect storm, right? But here's the thing that gets me. Because I talk about this with people all the time. And this is where I get into testability. Testability isn't just running tests. It's always asking, how am I going to test that? How am I going to test for this? How am I going to test for that? That's by making your system testable. And you have to design it so that it's testable. So any of these things, they removed old code and added new code at the same time. Just don't do that. But if you're going to make a policy that you're not going to allow code to be removed and new code to be added at the same time, how are you going to test that? Are you going to have something, you're going to set up your CI so that it'll prevent it? Kind of like making your strong type prevent somebody from mixing the bid and the ask? How are you going to test it? And I'm not here to tell you how to test everything. I'm here to raise these questions. They reused an existing value for completely different functionality. So just think of it easily enough as I've got these enums. I've got this enum x, and it's equal to 10. I don't no longer need x. I'm going to now name it y, and I use y. Just don't do that. That is just bad. Sometimes you have to because you only got 8 bits. I only got 8 bits. I have to do something, so I have to reuse one. Okay, then how are you going to test that? How are you going to test it you don't mess it up and get it wrong? And if you have a policy that you're not allowed, so in January 2013 or January 2014, I can't remember, I went back to work for a guy that used to work for me, and we built an exchange system, and a complete exchange system. It was 2013, a complete exchange system from the ground up. I examined this case in detail. I put in place in our SDLC, which is a software development lifecycle, testability plans for every single one of these occurrences. Not me, our team. It's like, how are we going to test this? How are we going to test it? It's like the question I'm asking all the time. How are you going to test that? How are you going to test that? How are you going to test that? All this complex interaction.
So in their case, do you know why they made the choice of reusing that bit? Or?
It's not part of the public information, and I don't really want to talk about anything that's not part of the public information because I may go off script, and I don't want to go there.
Okay, so but like publicly, we don't know if they actually needed, like if they only had 8 bits or something with that.
No, it's not part of the public documents. Just they made the decision. Okay. They stopped using PowerPeg in 2003, but that dead code was still around in 2012 to basically sink the company. If they'd have just removed it in 2003, none of this would have ever happened. How much dead code you got in your code base? Here's the thing. All right. And if you want to say, I don't want any unused code in my repository, how are you going to test that? Because, it's one of those things, right? You're getting the point. If you want to have a policy about your design, your API design, or this is your system design, then you better ask, first and foremost, how am I going to test that? Because you need to test it. Because it doesn't matter how well-intentioned you are. The new RLP functionality worked flawlessly. They had a manual deployment and no review and no tests. You don't do manual deployments. Really, this day and age, you should never be doing manual deployments. Ever. For anything. So that means you're going to do automated deployments. Well, how are you going to test that? How are you going to test that the deployments are actually there? They deployed stuff to 7 of them and not 8. We had a bunch of servers. It's a whole entire exchange system. How are you going to test it? They're all running compatible versions. Your system has to be holistically support versioning together. Well, number one, how are you going to test it? And then how am I going to implement it? Right? But you have to be able to test those things. And there was no review. So if you make a policy that you have to have a review, how are you going to test that it's been reviewed? Maybe you use a system that requires that someone has signed off that they've reviewed it or something. But how are you going to test that? And they had no system tests, which was probably the worst thing to me, right? Because all these other things are just mistakes. But it's a system that goes out. You should at least have system tests that must be run. And these tests aren't unit tests. They're not TDD stuff. They're basically, here's my system deployed. I need to make sure it works as it's supposed to work, right? So how are you going to test your system holistically? Which obviates all the discussions about testing techniques. Yes?
Is that all true for the rollback too? Like they manually deployed the rollback, no review of the rollback, no test of the rollback, like everything?
Correct. If you are going, and that's what we did. We had a plan for rolling back. You have to test your rollback strategy. If you're going to have automated failover, how are you going to test that? So your most important design decision of any API ever is how you're going to test it. Email for important log messages. Well, if you're going to send messages, how are you going to test that? Well, that has to go to a person. Then I don't know. Maybe what you do, how do you test it? Somebody's going to read it every day. Maybe randomly every day you put something in that they have to report. And if they don't report it, they get in trouble because they missed it. Because you need to have those people on the ball. Now, that's a horrible system because you've got a human directly involved. And what's the first thing you know about all humans? They make mistakes. All those other humans make mistakes. And the rollback made matters worse. Understand what your rollback strategies are and test them. How much time I got? 20? Great. I was going to go back and talk about these in more detail, but I think we discussed them enough. But you have any questions about any of these? I'll be glad to answer that or discuss any of this. Yes?
So, in my experience of the finance industry, when I first joined, the thing that took me by surprise was, maybe this isn't true for the whole industry, but the cadence of the exchange, like the daily cadence, that's not, like, the world doesn't work that way outside the finance industry. No one turns off software, right, in the real world. But in the finance industry, because the exchanges have this daily cadence, it leads to so many poor practices. Like, if you're forced never to turn off software, these kind of things you just can't do. But they're rife in the finance industry.
It's less true than it used to be. FX stuff is around the clock now because it goes through every time zone.
Well, you'll have. Well, NYSE also has a proposal for 24/5
and crypto.
Yeah.
So it's maybe becoming less true, but I think it's still a legacy.
It is. It very much is, because the market in the U.S., the markets are basically Monday through Friday, 9:30 to 4, right? And the options and some of the other markets, there's a little wiggle room on there, but that's basically it. Then you have this trading day, and what happens is it's a race. The first one to recognize an opportunity gets it. Nobody else does. That's a overgeneralization that is a lie, but it's really. So people are trying to make sure all their stuff's ready to run. You get ready, you run, you come up, you run and you race. People in this industry, from the time the market opens to the time the market closes, you are. I don't. Tight sphincter, maybe? Is that a reasonable way of saying it? It's a bit of pressure, especially if you don't have confidence in your systems. When we deployed our system, a month before it got deployed, the person that had given us the requirements was just wrong. I had argued with this person until I was blue in the face, and he said, "No, this is how it works." So I implemented it. We have it out in test. Customers are yelling because it's doing stupid things. I'm like, that's what he told me to do. I argued with him and he said, "No, this is how the system works. It's our secret sauce." Have to change the whole thing. The whole system, because of what he wanted, the design was made to do what he wanted quickly. I had to rewrite the whole thing. I had to rewrite 75% of the whole entire guts. I did. I basically said, I'm going to rewrite everything until all the unit tests pass, and then I'm going to rip out those parts. And I rewrote stuff until all the unit tests passed. I ripped out those parts, ripped out those unit tests, and I put it into production. And I had full confidence in doing it because I at least believed that it was well tested. I see a question back there somewhere.
So if you're a market maker and if you find a bug when the market is trading, what's the best practice?
Your company has to determine that best practice, and they have to register that with the SEC. You have to have a best practices, and I'm not gonna say what that should be because I'm not a regulator. I'm a programmer. I have my own opinions about those things, but in general, you need to have some type of the red button. You have a kill switch. We had ways that we could kill certain models, specific models, and ways to shut the whole system down or deny people trading. But these people have obligations to be in the marketplace. You just can't shut the whole thing down willy-nilly, right? So it's very, very regulated. If you want to know those types of things, I suggest you read that whole entire paper.
Can you clarify what the difference between the reuse existing value and the different view of the same thing is? Or what is the second one?
The difference between what?
Reuse existing value and a different view of the same thing. What's the second one referring to?
The different, this one? Yeah. This one is where once the PowerPeg functionality was running, they were basically they were sending off child orders and they were being executed. One part of the system saw the execution and was doing the accumulation correctly. But the system that was actually generating the orders was not doing it correctly. And so that's where you've got systems that are cooperating. One part knows about, and And that's what I mean by different components had different views of the same, it was the same events going on. One had an accurate view and one didn't.
Do you have like any I don't know, like ideas of like what the penalties are for stopping trading on the market?
Yeah, I don't want to get into that. It doesn't have anything to do with programming.
Okay.
I do have an idea of what they are, but I really don't want to get there.
Okay, I get that. Like, I'm just trying to put myself in their shoes of like, I'm losing millions of dollars, but I'm gonna deploy code with no testing.
No. You've got it all wrong. One of the problems is that the programmers were trying to figure this stuff out. Yeah. The programmers are programmers. They are not the people that make the business decisions. And just read, if you want to know those, I promise you, that information's in the paper. Okay. Go read the filing. Were you going to say something? Anybody else? Okay, so we can move on. I wonder if I have enough time. 15 minutes. Ooh. I have enough time to make you mad at me. I don't have enough time to make you unmad at me.
Perfect.
Because the plan was to make you mad at me, but then explain why you really shouldn't be mad at me. But I think all I have time to do is make you mad at me, if you're not already. So basically, I posit that any of those things should be done. Here's one thing I do want to talk about, generated code. These are all supposed to come up individually, but I messed it up. So we'll do them all together. In this industry, you generate code. Most shops generate code in some degree or another. If you're going to generate code, it means you're going to write a code generator. How do you test it? How do you test the generated code? How do you code review the generated code? Me. Always commit code generated from your own generator into the source repository. This is one of those, remember I said earlier where you can disagree on stuff and you have to be willing to compromise? This is a line in the sand. I will never, ever compromise on this.
You're a monster.
I know everyone else says not to do that. And I used to be part of everyone. Everyone else is wrong. I learned the hard way. Not as hard as night, but hard enough to never repeat that mistake again. Now, I'll tell you why I won't tell you the event that occurred, but basically, if you have your own code generators, who's writing them? Humans. You're going to make mistakes. And you're going to have something that's not caught in a unit test of your code generator. But you know what you can do? If you generate your code and format it and keep it in source control, when you have the diffs of the code generator, you can actually see the diffs of what's actually being generated as well. And so you can tell what the differences are. If you just generate them into a build directory and never look at them, I'm just saying, you do that. I will never, ever, and I don't care what pains it causes me in CI, I don't care what pains it causes me in Git, they're worth it because none of them come close to touching the pain and agony of that. Okay? I'm just saying, think about it. Yes?
Okay. Yeah. Compiler is one of the code generator. So,
yes.
I mean, you are talking that you are saying that we need to review the binary?
No, what I'm saying, so I'm going to trust my compiler that it's generating the right code, but I not only. So when I have control of the build system, I will build debug, release on every compiler that I can and every version of the operating system, and I will make multiple builds on multiple different compilers and run all the tests on all of them in both debug and release to hopefully, if there's a code gen problem, I'll catch it. I don't write tests to try and test the compiler. But anything I write, I trust me much less than I trust the compiler writer. And it's just like when I'm compiling code. Oh, there's an error. That should compile. That stupid compiler. How is it wrong? No, it's usually my fault. So what I'm talking about is code generators that I write. Or code generators that I use from somebody else that maybe is less trustworthy. Okay? Yeah. All right. So here's where I get in my grandpa chair and I just ask, can we talk? I want to talk about something that I think is quite controversial within the C++ community, which means you guys. Why do I feel that it would be controversial? Well, because I've talked to a number of people within the C++ community, and they've told me that it's controversial. Sometimes not in those nice words. It's object-oriented programming. It's kind of a pet peeve of mine. Oh, you know what? I forgot to go through all my nice books. Classical and object-oriented software engineering. Awesome. All this UML stuff. It's good to an extent, but I don't have time to talk about the stuff I was going to talk about there. But the rest of the stuff actually might still apply. It's object-oriented programming. So why is this so controversial? At the beginning of the talk, I told you I'm going to give you an opinionated talk. And a lot of the stuff I have, they're opinions. That's what they are. The thing about the committing generated code, it's an opinion. But I will never change it. But it is an opinion. You can have a different opinion, and that's fine. Almost, yes?
Are you meaning real object-oriented programming or what C++ calls?
That's a very good question, Ben Dean. It's almost as if I planted you there. It's controversial because maybe I should show you. You know what I'm going to do? I'm going to do this. I'm going to actually read my notes directly so you can see how in tune Ben and I are. So why is this so controversial? Because almost every C++ programmer does object-oriented programming, and there are multiple talks about object-oriented programming at almost every C++ conference, and it's almost all wrong. Now, I wasn't going to read it like that, but that's kind of like my notes, right? The crib notes thing. So how's that controversial? Well, because obviously I can tell that not all of y'all don't agree with me. Some of you might. So name the top object-oriented programming languages. Just name them off. I'm sorry? Java, Smalltalk, Ada,
C#,
Objective-C. Okay. Anybody know this guy? Alan Kay. He invented the term object-oriented programming. He invented the term. He claims he invented object-oriented programming, but other people claim that, and he does too, right? He got the idea from Sketchpad and Algol, right? Which is similar to how Strostrup came. They both have similar backgrounds, but anyway, so he came up with the term object-oriented programming. So he named it, all right? And according to him, there are two object-oriented programming languages that he knows about. Smalltalk and Lisp.
Oh, close. Yeah.
Okay? Now, my claim, and I go into it later, but I'm going to get beeped soon, so I'll just tell you, my claim is that when you do object-oriented programming correctly, you have to squint for it not to look like functional programming. I made up the term object-oriented, and I can tell you, I didn't have C++ in mind. Now, this talk was his OOPSLAW talk, I think from I don't remember when. But look it up. This is a great, I think it's an hour and a half, maybe 2 hours long. It is fabulous. The whole entire thing is fabulous. So, my background. So when I was in grad school, my focus was in AI. This was back in what's called the AI winter. I wrote expert systems that determined where you should drill for oil. That was sponsored by a consortium of oil companies that was used. It was basically based on a mixed initiative, Dempster-Shafer belief propagation, both forward and backward. You take the belief probabilities and you propagate them both forward and backward, and that was written in Lisp. My other project that I did while I was in grad school was this, the only book on my table that Ben Dean hasn't read. A general qualitative simulation methodology. This was my master's thesis. You recognize this stuff in the back? That's a printout of the source code. What language is that? That is Smalltalk 80. That is Smalltalk. That is these books. Okay? Smalltalk. Smalltalk 80. Why is it 80? Oh, I just blew up my thing. Hang on, let me see if I can put it back on. It was Small Talk from 1980. Okay? 5 minutes, crap. I may not even have time to get you really mad at me. All right. So I love listening to Small Talk, but I didn't know it then. Please do not look this up. Do not read the code at all. Just please don't. It's crap. The ideas are nice. The code is total crap. I didn't understand it at the time. So what defines object-oriented programming? This is going to be different because unless you've been through object-oriented programming for real and not what C++, what most C++ practitioners call object-oriented programming, and it's not Stroop's fault, I blame it on what I call the industry of practitioners who make their living telling other people how they're supposed to write and build software. And that ekes down into the school community, and that's what professors teach people. And so you have a whole generation of people that come up and think they're doing object-oriented programming, and they're not. Encapsulation. But encapsulation doesn't mean what you think it is, because it doesn't mean what Wikipedia says it is. Because whoever wrote the Wikipedia thing didn't really know what encapsulation really is. At least according to how Alan Kay defines it for encapsulation. So object-oriented programming, encapsulation. Local retention and protection and hiding of state process. When he describes this, he says, think of an object as a server. It may have state that gets modified. It may just have process. But that whole thing of what it does is encapsulated. It's hidden. It's hidden. How do you communicate? By message passing. This is the main idea of Smalltalk and of object-oriented programming. Object-oriented programming has almost nothing to do with objects. It has everything to do with message passing. Messages can't be commands. What does that mean? It means that you can send a message to an object. I can send a message to the Shay object, and you can just ignore it. Or you can send me back a not implemented, right? But they're not commands. They're just requests. Message passing is the most important concept in object-oriented programming. He says that he wishes he'd have never called it object-oriented programming because because of that, people thought that the important thing was the object. And it's not. The object is completely incidental. The third thing is very late binding. This is not virtual functions. This is an object being able to change its behavior. This is, in the C++ world, this would be sending a message to an object and having it reload a DLL and change its virtual table somehow, right? That's what late binding is. You change behavior. An object can change behavior. Late binding. Yeah, even behavior. So what is the stuff that most of the industry calls object-oriented programming? Well, Alan Kay, he's nicer than me. So he uses real object-oriented programming for the OG stuff. That's what he started calling it, just real object-oriented, real OOP. But why should the OG have to change names? That makes no sense to me, at least where I grew up. I propose pseudo object-oriented programming, because that's what it is. It's pretending to be object-oriented programming. It even comes with its own acronym and its own emoji. So let me explain. If I have enough time to explain, I probably don't. I'll explain for as long as I have. People either love or hate C++ object-oriented programming. Those that love it for the wrong reasons and those that hate it for the right reasons. But their hatred is for the stuff that we try to do when we're trying to simulate OOP with an incomplete understanding of what OOP is. And it's very difficult to get C++ people to stop and think about messages are not functions. Messages are messages. Messages is, here's how I want you to think about it, because I don't have very much time. Think of an object having one function, the call operator. And even think of it as a templated function. And every time you want something to do, you pass it an object. And it has the ability to not stood invoke what you're telling it to invoke. This is how we would deal it with a compile time, right? It can either be there or it cannot. So a message is bound to some piece of behavior or functionality. That binding in Smalltalk is implicit when you define a method. Please stop calling member functions methods. They're not. It's another pet peeve of mine. They're not methods. They have nothing to do with methods. A method, the word method came because it's the method of implementing the process or the functionality for a particular message. You bind methods to messages. And because people use that term to refer to it as functions, that's part of why we don't understand the concept of object-oriented programming. They are completely separate concepts. So I've heard all week people pooping on object-oriented programming for one reason or another. And they're not pooping on object-oriented programming. They're pooping on pseudo-object-oriented programming. And I actually tried to get a little thing where like a whole bunch of little poopy things flew down, but I ran out of time. So it's similar to true object-oriented programming in name only. And that's not true either. It's kind of a bit extreme. But I've already offended a whole bunch of people, so give me that much. So if you want to see my understanding of object-oriented programming, there's this talk, the CppCon, in 2022, using modern C++ to revive an old design. In there, I basically talk about what was invented a long time ago, too, for Unix, called System 5.4 streams, which is basically modules that get put on top of one another. Today, you might call each one of those modules an active object, but it's not quite like that. And you just pass messages between them. And they're extremely composable and extremely testable. You want new functionality? Add a new module in between, and you don't change a line of code. If you add new functionality to your code, and you have to change one line of code, aside from just the part that plugs it in where it's supposed to go, then you did it wrong. It's very modular, it's very open, but you think of each one of these as objects. I'm just passing messages. And the thing about streams, here's what streams does. Chris, if I send you a message, and you don't understand that message, you don't yell and send an error, throw an exception. You go, hey, I don't know how to handle this thing. Maybe the next guy down the line does. So I pass it to the next guy. And on and on and on. And we can build these abstractions. All the way, the problem is performance. All of this data, you have to inspect at runtime. This talk and this one, which I gave at C++ on C the following year, talk about a way to do this all at compile time and take away all that decision making at compile time. So at runtime, you are making no decisions, but you still have all the modularity, you've got the functionality. And so I'm not telling you to go use this thing because I still don't even have it up on GitHub for people to use. But I'm telling you to think about it, because if you can build units of code that are individual composable modules, they are independently testable, and they are composable in long runs where you can test the whole entire functionality of it. It's a great way to do it within C++, and I argue it is infinitely closer to object-oriented programming than what we see people calling object-oriented programming. Now, I'm not saying that code is bad. They want to do it fine. We talk about dependency injection. Why do we need dependency injection? Because we have these hidden dependencies within our stuff. Build things as functions. Build them as pipelines. You want a logger? You want something to log stuff? That's fine. I'll just generate a message to the logger. If it's there, the logger gets it. If the logger's not there, it's a no-op. I don't need to know it. I don't need to have some global singleton of a logger to do logging. You want to do performance benchmarks? You insert a probe at one point in your stream. You insert another probe at another point in your stream. Now you can measure every single command coming through your stream, and you've not changed a single line of code. So object-oriented programming, it's all about the message passing. So if you want to do object-oriented programming, it's all about the message passing. This, I believe, is very similar to functional programming, and it makes your C++ code very, very testable. Though, I'll argue, you shouldn't just worry about testing your C++ code. You should worry about testing your entire system, as we witnessed with Knight. So that's it. I don't know if I have any time for questions or not. If anybody has any other questions, I'll be glad to take them. As long as until until Shay tells me I can't. Anybody got any other questions?
I think we're going to have discussions after. That's going to happen.
Okay. All right. Yeah, I'm definitely open to discussions afterwards. Anything else? Great. Thanks for coming. Like I said, I was afraid it was just going to be me and 2 or 3 people. So it was great to see you guys. Thanks.